Assalamu alaikum. This is Altex, as you all know. Today we'll be going over circuit switching and packet switching, which is part of communication and internet technologies, which is chapter 2 of 9618 A2 level. So we'll be going over specifically circuit switching and packet switching, right? So circuit switching is a method of transmission in which a dedicated circuit lasts throughout the duration of the communication, right? So there's this specific one line which lasts throughout. Here each connection is leased. The type of medium of the data sending is full duplex, and here we can see there's a highlighted connection that I have drawn out, which shows that there is one specific route that is being followed throughout. So from device A you go to router A, and then you go through all these routers to router B and device B. This does not change throughout the circuit switching because you have technically leased this whole line for the duration of your call, right? So there's three stages of circuit switching, right? So prior to the conversation that happens, prior to whatever you need circuit switching line for, you need to first establish a connection, first establish a channel or a circuit between the sender and the receiver, right? And then data transfer takes place. This can be analog or digital, and transmission is usually bidirectional, meaning that you can talk to the person and the person can reply back. That is how video calls work, which use circuit switching, right? And this is also used in public telephone system networks as well. And after the data is complete, the connection is then terminated, right? So now circuit switching and pros and cons. The circuit used is dedicated to the single transmission only. So when you have leased a line, it belongs to you and the person you're talking to. So it's just you, the sender, and the other person, the receiver. So it can only work that way. The whole of the bandwidth is available because the whole line is leased to you. The data transfer rate is faster than with packet switching. We'll discuss packet switching later on after this. The packets always arrive at the destination in the same order as they were sent. Now this is because they're always following this dedicated line, and when I speak, right? So take for example, if I'm on a telephone call, so first my voice, each sentence would go in order, right? So it will go to R2, R5, R8, R7, R10, and this will happen for the same person. When he speaks back, it will follow the same, just inverted path, right? So that is how it works. And a packet cannot get lost since they all follow the same route in a sequence, and it works better than packet switching in real-time applications always, which is phone calls, video calls, live, take for example an online game, right? But it is not very flexible because take for example if you're idle, right? So no one is getting to use the circuit channel, and it's just going to send empty frames because you're not speaking or your video is off, right? So there's no way it can send anything, you can give the line to anyone else during that time because you've already set prior to it for between the sender and the receiver, right? Okay, the circuit is always there whether or whether or not it is used, right? So take for example, if you're not using it, as I said, it's going to remain idle. If there's a failure, there's only one route, so you cannot reroute. And dedicated channels require a greater bandwidth. Even though you have the whole of bandwidth, you might have to pay more because you're getting a whole line with a greater bandwidth, right? And prior to actual transmission, you need to set up a link, right? And that link setting up time can be long and add up to waiting time, right? Now we move on to packet switching, right? It is a method of transmission where a message is broken down into packets which can be sent along paths independently from one another, right? Here are four packets. They are split into twos. So two of them are going to R2, two of them are going to R6, and then they're further split and they're going to different routers in this way, right? And here they're arriving in order, and here they're going to computer B in order, but they can arrive out of order, and then your computer might have to make them in order again, right? So we'll be going over that as well. So each packet follows its own path. Routing selection depends upon the number of datagram packets waiting to be processed at each node. So each router might have already a line of packets waiting to get routed further, right? So you might have to wait. Your packet, one of your packets might have to wait. The shortest path available is always selected, and packets can reach the destination in a different order to that in which they are sent. So here are some pros and cons for packet switching. no need to tie up a communication line because each packet takes up different routes, right? It's possible to overcome failed or faulty lines because it's just going to get ignored and another route is going to be selected. So it's easier to expand the traffic usage. Circuit switching charges the user on the distance and duration of the connection, but packet switching only charges users for the duration of the connectivity. High data transmission is possible with packet switching because it's splitting your packets and then using different lines. But packet switching only supports digital networks, which means digital data is transmitted directly to destination, whereas in circuit switching we could also use that for analog, which is your old phone calls, PTSN. Here are some cons for packet switching. The protocols might be a little more complex. It might take more time to set up, which means that you might have to wait more for your message to arrive to someone else's place, right? If a packet is lost, the sender must resend the packet, which wastes some time. Does not work well with real-time data streams because packets may arrive out of order. The circuit channel has to share its bandwidth with other packets. So sometimes, even though it needs to be faster, you might have to wait more because there might be a line of other packets waiting to be processed to the other node. There's a delay at the destination while packets are reassembled. So if the packets do arrive out of order, so there needs to be reassembly, right? And needs large amounts of RAM to handle the large amounts of data and to reassemble as well. Now we'll be going over the comparison of circuit switching and packet switching. So for circuit switching, a line needs to be set up prior to the communication and a dedicated transmission path is required. And each packet uses the same route. As we discussed, that is only going to be one route, whereas in packet switching, there isn't one route. Every packet can be rerouted depending upon the availability of the second or third or fourth router, or how many routers there are between. And all the bandwidth of the channel is required in circuit switching, whereas packet switching can work with sharing. Packets arrive at destination in correct order. That is true for circuit switching because they travel in one dedicated line, whereas in packet switching they do not. Is bandwidth wasted? In circuit switching, it definitely is because, take for example, if your line is idle, right? So nobody is using it, it's just sending empty frames. So that is when bandwidth is being wasted. Whereas in packet switching, there's no packet from your specific data to be waiting to be processed. Then it can be done for any other data that arrives, any other packet that arrives at any node that is in the dedicated line system of the network there is available. So that is it for circuit switching and packet switching. There's going to be more. Stay tuned. Allah Hafiz.